we're looking at some reaction coordinate diagrams and interpreting the effect of an accelerator catalyst. An accelerator catalyst increases the reaction rate by lowering the activation energy barrier. The activation energy is the energy between the reactants and the top of this hill, the energy required to go from the products to some form of an activated state or an intermediate complex. And we see that in reaction coordinate diagram B, the activation energy is considerably smaller. So B is going to be the catalyzed reaction. Want to stress, however, that delta H of the reaction is unchanged. Let's see that on the reaction diagrams. Delta always corresponds to the product state minus the reactant state. So we can determine delta H off of this graph, because here we have the energy of the products, and we start here with the energy of the reactants. So we would have delta H is going to be an energy of about 5 kilojoules per mole minus, let's say, 12. So this is going to be equal to a negative 7 kilojoules per mole. And that's exactly the same as in the catalyzed reaction. So delta H is also minus 7 kilojoules per mole for this exothermic reaction. Looking at the second set of coordinate diagrams, we see that the activation energy for the second is much smaller. So this is going to correspond to the catalyzed reaction. And again, we see that delta H is unchanged from the catalyzed to the uncatalyzed reaction. Okay, the delta H of the overall reaction is again unchanged. Okay, we can estimate the value for delta H by looking at the reaction coordinate diagram and indicating that delta H of reaction is going to be that of the products, which looks to be about 15 kilojoules per mole, minus that of the reactants, which is, let's say, about 2. And this corresponds to about 13 kilojoules per mole. Endothermic, since delta H is greater than 0, and we have the energy of the products is higher than that of the reactants. And in the catalyzed reaction, we have the same delta H. So the activation energy is lower in the catalyzed reaction, but our value of delta H for the overall reaction remains unchanged.